Hello everyone, I'm Santi Marchetta, PhD student from University of Messina, and this work is about the validation of notch stress intensity factor, strain energy density, and effective notch stress approaches in fatigue life assessment of austenitic steel welded joints. Most of the international design codes adopt the nominal stress criterion, which correlates the fatigue life of welded joints with stress values calculated at their critical cross-section. However, as can be seen in the example reported on the right-hand side, when nominal stress-based fatigue data related to different joint geometries are elaborated, a significant scatter is usually observed. This criterion indeed does not account for the local stress field at well-chosen roots, which is the main responsible of the fatigue damage mechanism. To overcome this limitation, several numerical approaches such as notch stress intensity factor, strain energy density, and effective notch stress have been developed over the course of years, which express the fatigue life as a function of local parameters evaluated at the weld notches, where cracks usually initiate. These methodologies were validated for materials such as structural steel, aluminum, titanium, and PMMA. The aim of the present work is to verify the applicability of N-SIF, SED, and ENS approaches to the fatigue assessment of austenitic steel welded joints. The chart reported in the slide provides an overview of the proposed workflow. Literature fatigue data from cruciform welded joints in austenitic stainless steel were reanalyzed using finite element models and were expressed in terms of nominal stress and SIF, SED, and ENS to compare the resulting scatter. Further details are reported in the manuscript. Statistical analysis of the various representations of fatigue life highlighted an evident scatter reduction as the representations shift from nominal stress-based representations to N-SIF and SED-based representations. Overall, N-SIF and SED approaches appear to provide a more unified treatment of the fatigue behavior of austenitic steel welded structures. On the other hand, the NS method still exhibited a pronounced dispersion of the results. Nevertheless, the limited size and scope of the analyzed dataset prevent any definitive conclusion from being drawn. A more solid validation could be achieved by enriching the current dataset with a sufficiently large and diverse number of data points.